the countdown.
Congratulations! This live broadcast is specially brought to you by Academy YouTuber Malaysia, an initiative by Didik Malaysia and Kelab Guru Malaysia. Please pay attention. The live broadcast will begin shortly. The link to the certificate of attendance will be provided at the end of the session. Please make sure it is filled within the stipulated time. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum. Good evening and hi to all teachers, parents and the wonderful students. Welcome to Pusat Tuisyen Academy YouTuber, a joint venture with Didik Malaysia and Kelab Guru Malaysia with the hashtag bermula percuma, selamanya percuma. Okay, before we proceed, let's begin our session with the recitation of Umur Kitab Al-Fatihah. For the non-Muslim, please take a moment of silence. Okay, how is everyone doing today? My prayer is that everyone is in the best of health and ready to proceed with today's class. So let me introduce myself first. Okay, I am Madam Rosmaya as your moderator and also a control host for today. I am a Form 6 physics teacher at SMJK Yuhua, Kajang, Selangor. And the most important person today is our presenter, Teacher Nun. She is from College Matrikulasi Negeri Sembilan. So let us give a warm welcome to our presenter. Okay, even though there are only two of us, but we will make sure that today's session runs smoothly. Okay, for the record, we are now live on Teacher Nun channel. So as a sign of support to Teacher Nun for the hard work in preparing today's lesson, so please subscribe to her channel. Okay, and not forgetting my channel too. Okay, as usual, the lesson will last approximately 1 hour. Okay, the certificate link and the credit claim link will be given at the end of this session. Remember that you can only use EDD email and more email to claim the certificate. So for credit claim, you need to collect 1 letter and 6-digit codes. I repeat, 1 letter and 6-digit codes, which will be announced separately 3 times during our class today. So be sure to follow the class up until the end to get the complete code for the credit claim. Okay, I would also like to remind students to use appropriate language and also use appropriate profile picture if you wish to post comments in the chat box. So I'm pretty sure all of the students here are excellent students who will uphold a positive classroom environment. So please give your full cooperation in making this class a lively one. So stay focused, and if you have any questions, please write on the chat box and Teacher Non will try to provide you with the answers. So before I pass this session to Teacher Non, okay, I will announce the letter and the first 2 digits code for credit claim. Okay, the codes are A18. Okay, A18. Okay, so without further ado, please welcome Teacher Non, okay, to start your presentation.
Okay, thank you so much, Madam Rosmaya. Hi, everyone. How are you? So I hope that you are in the good condition, good health. So welcome to Pusat Tuisyen Academy YouTuber. So for today's class, welcome to my class. We will discuss about the problem solving for the topic capacitor and dielectric. So before I start, I want to introduce the Academy YouTuber team, which is the first slide showing that this is the physics team. It is very special. The physics team is led by Madam Rosmaya. And here are Teacher Sue, Teacher Habsahayu, and also me. Okay, then we have the mathematics teams, which is led by Teacher Im. And then we have biology Prayu team, led by Cikgu Faiza. And we have Kimia Prayu team also, which is led by Cikgu Shahnun. And we have the Perakaunan and Ekonomi Prayu team, okay, led by Madam Fizi. Okay, so Academy YouTuber also have apps are very very special, so you can download from the Google Play Store. Okay, there is a lot of video there, include the video for the physics subject. So if you want to refer, you can refer to these apps. You can download the apps. Okay, now before we will continue. Okay, so for today's class, I will discuss the problem solving about topic 2, which is about the capacitor and dielectric. Actually, the first part of today's discussion, I will explain about the conceptual part for the capacitor and dielectric topic, and then we will take a look at the few questions that relate to what you're supposed to learn in this chapter. Okay, so take a look at the first. Okay, actually, capacitor and dielectric topic, they are divided into 3 subtopic. Okay, the first subtopic is about the capacitance and capacitor in series and parallel arrangement. So first, you're supposed to know the definition of capacitance. What is capacitance? So the capacitance is defined as the charge on either plate, represented by Q, to the potential difference V between them. So given by the equation of C is equal to Q over V, and the unit for capacitance is farad or coulomb per volt, because of charge is coulomb, potential difference is volt. And then about the arrangement of the capacitor. So for the arrangement of the capacitor, we will calculate the effective capacitance of the capacitor. There are 2 types of combination, which is the series combination of capacitor and also parallel arrangement of the capacitor. Okay, in this case, we discuss in terms of the capacitance, which is C is equal to Q over V. So we will discuss the terms of capacitance, V is potential difference, and Q is the charge of the capacitor. So for series combination, to calculate the effective capacitance, we will use the equation of 1 over C effective equal to 1 over C1 plus 1 over C2 plus 1 over C3. So if you calculate, you will get the effective capacitance for the series combination of capacitor. For the parallel arrangement, we just add the capacitance for each capacitor. So you will get the effective capacitance. And for the potential difference and also the charge of the capacitor, it is very easy for you to remember, because of for the potential difference, just remember for the parallel arrangement, normally the voltage or the potential difference across the parallel arrangement is equal. So we can say that the effective or the total voltage or total potential difference is equal for the circuit is equal to the potential difference across capacitor 1, the is also equal to the potential difference across C2, and also equal to the potential difference across the C3. But for the series arrangement, to calculate the total potential difference, we need to add all the potential difference for each capacitor. And for the Q, it is opposite with the potential difference, where for the series arrangement, the total charge in the capacitor is equal for each capacitor in series. And for the total charge for the parallel arrangement, we need to add the charge for each capacitor. So this table actually can help you if you want to solve the question that relate to the arrangement of the uh, capacitor, either series or parallel, or it can be combination of arrangement, which is in a circuit there is a series combination and also the parallel arrangement. Okay, the next one is you will learn about the energy store in the capacitor, which is represented by U. So of course this is energy, the unit is joule. And for the capacitor, there are 3 equations to calculate the energy store. You can choose either one. Okay, actually the difference is only, let's say if you have the equation for energy store, which is half QV. Q is the charge of the capacitor, V is the voltage or the potential difference. So it is depends on either this equation or these two, which one you want to use. If you want to solve the problems, it is depends on what is given to you in the question. Let's say if given to you the charge and the potential difference, so you need to choose this equation. But let's say if in the question given to you the charge and the capacitance, okay, the voltage, the potential difference is not given to you. So what we supposed to do, referring to the definition of capacitance, we just rearrange, we change V, because of we have no value for potential difference, so V is equal to Q over C. We just replace Q over C in this equation, then we get half Q square over C, just like that. Okay, same thing if we do not have the Q. So what happened? What we do? Q, which is equal to CV, we just replace in this equation. So when we replace Q as CV, you will get that the potential energy stored in the capacitor equal to half CV square. Meaning that if you have no value for one of the terms, so you can change the equation. Okay, so that's the first part, first subtopic for this capacitor. And for the second subtopic is about the charging and discharging of the capacitor. So I discuss whole relate to the concept first, and then we do the discussion on the problem solving. And for the charging and discharging of the capacitor, the very, very important terms that you're supposed to know is times constant. When we talk about the charging and discharging process, it is related with the time constant. And the definition of the times constant is the product of resistance and capacitance, which is represented by the equation of tau equal to RC. So actually time constant, the symbol is tau. Okay, and the unit, because of it is time, so it is still second unit, and it is a scalar quantity. Actually, if you want to understand what is time constant, it is a measure of how quickly the capacitor charge or discharge, meaning that it is related to the process of charging and discharging of capacitor. And I will show you the difference between the charging and discharging of the capacitor. Okay, so this table shows that the process of charging and discharging, the different. So there are few terms that when we want to differentiate or we want to understand the charging and discharging process, we can compare between the circuit, between the graph produced from the charging and discharging process, the equation, and also the time constant definition for each process. So now we take a look at the one by one and we will compare. So the first part I want to compare is the circuit. So this is the circuit diagram for the charging process and also the discharging process. Can you see what is the difference between these two circuits? So if you look at when we charge a capacitor, we need to connect to the power supply, battery or power supply. But when for the discharging process, there is no power supply because of during the discharging process, we use the charge that stored in the capacitor. Okay, the charge will flow in the circuit from the capacitor. But for the charging, of course, lah, the charge is produced from the power supply. Okay, and for the graph, when we compare between the charging and discharging, of course, this is the graph of charge against time. Okay, so meaning that how many charge is stored in the capacitor during the charging process. So this is the graph which is showing that the increasing of charge to the time. And we have very important point here, which is we have the definition of time constant, right? You learned before just now. So times constant for the charging process is located for when the charge is increased to 63% from its initial value. So times constant is represent when the charge increase during the charging process, because of the charge is increased 63% from the initial value. But if we compare for the discharging process, if you look at here, shows the decreasing of charge during the of with the time. Of course, because we will use the charge, right? Because of, for example, our handset, our handphone, our battery of the handphone, when we use it, the charge will decrease. You can see the battery symbol at your handphone. So for the discharging process, the time constant is represent when the charge decrease to 37% from its initial value. Okay, that's the difference between the charging and discharging process for the graph. And for the equation, so this is the equation for the charging and this is the equation for the discharging process. So the equation is represent from the graph. Okay, increasing of the graph. So this is the Q and Q naught is the initial charge. Okay, same thing with the discharging process for the equation. How about the time constant? How we define the times constant actually, if you refer to the graph charging and discharging process. So for the definition of the time constant, we can state that for the charging process, the time required for the capacitor to reach 63% of its maximum charge during the charging process. So it is specific. Kalau for the charging process, the charge will reach or increase to 63%. We need to set like that. And for the discharging, meaning that for the time constant, when you want to define it, it depends on the process that given to you. So you can define in terms of if the process is charging, so you refer to increasing of the charge 63% from its initial value, or for the discharging, You can mention that the time required for the capacitor to reach 37% of its maximum charge during the discharging. Or actually not to reach, actually to decrease the time required for the capacitor to decrease 37% of its maximum charge during the discharging process. Okay, meaning that the definition of time constant, it is depends on the process, either charging or discharging. And for the current, so current, it is a special case for the current because of for both process charging or discharging. If you look at the graph of a current versus time, both graph for charging and discharging process is showing that the current is decreased with time. Okay, why? Because of actually during the charging process, when we charge, let's say you need, I just want you to imagine your handphone, and then you charge your handphone. When you charge your handphone, actually initially the battery is zero, right? There's no battery in your handphone, so it is a lot of charge can flow into your battery handphone. So meaning that a lot of current will flow. And when you charge at a certain time, maybe after half an hour or after 1 hour, you will see that the charge is increased, right? So there is the less current will flow because of the space for the charge to flow in the capacitor is decreased. Okay, meaning that the current finally slowly equal to zero when the capacitor is fully charged. That's why lah actually kalau if you charge your handphone, if it shows that fully charged, just disconnect with the power supply. Just disconnect, meaning that you just off the plug off, because of there's no point, the charge will not flow. Sometimes so we assume that when we charge longer, it is a lot of charge inside our handphone, right? Actually it is not happen. If the capacitor is fully charged, so it will stop flow, the current will stop flow. Same thing when you discharge, when you use your handphone, meaning that after the battery is full, so you want to use your handphone, so you will use it and the charge will flow. Initially it is a lot of charge in your battery, right? And then when you use it, when you use your handphone, the charge is, your battery is decreasing, the charge is decreasing, so finally it is a few charge in your handphone now, so the current is few current can flow. That's why lah, that's why for the charging and discharging process, the graph for the current versus time is decreasing. And of course, to define the time constant for the current, if given to you the graph for the current, so we said that the time constant is the time required for the current to drop 37% of its initial value during the charging and discharging process for both. But for the charge, it is charging 63% increase, discharging 37% decreasing. So you're supposed to differentiate. If you can understand the graph, actually it is very easy for you to define the time constant. Okay. And now we go to the third part, third subtopic for this topic, which is about the capacitor with the dielectric. So why we have the dielectric in the capacitor? So first, take a look at the definition of the dielectric constant, because when we insert the dielectric between the two plate of the capacitor, so the dielectric is with the dielectric constant. So the definition of the dielectric constant is the ratio between the permittivity of the dielectric material, which is epsilon, and the permittivity of the free space, which is epsilon naught. So the electric constant represented by epsilon r. Okay, epsilon r is equal to the ratio between the epsilon and epsilon naught. So epsilon naught meaning that permittivity of the free space, meaning that initially the capacitor is with no dielectric. There is only air field or the vacuum, okay, between the two plate. And when we put the dielectric between the two plate, so the permittivity of the dielectric material is applied for this question, okay, for this equation. And then we take a look at the effect of the dielectric. So what is the purpose of inserting the dielectric between the two plate of the capacitor? So of course, the important thing is it will increase the capacitance of the capacitor, and then it is also can increase its maximum operating voltage, and as mechanical support between the plates to be close together without touching. Okay, this is a few effect or few advantage of inserting the dielectric in between on a parallel plate capacitor. And there are the relationship between the capacitor with the dielectric and without the dielectric is, so for the capacitance of the, because we focus on the air field parallel plate capacitor, Okay, so if you have the capacitor with no dielectric, so when you want to calculate the capacitance, so which is represented by C naught is equal to epsilon naught A over D. And then when we put the dielectric, what we do, because of it will increase the capacitance, it will increase the C naught. So we just add, we just times the dielectric constant to this equation. So if you want to calculate the new capacitance, when you insert the dielectric, so it is equal to epsilon R, epsilon naught A over D. And this is the relationship, of course, between the capacitance with the dielectric C and the capacitance with the no dielectric. Okay, and this is another relationship that we can relate, referring to the relationship between the C, V, and E. V is potential difference, E is the electric field. Okay, it is relate. We will look at the few question later on. Okay, so I think that's it. Before that, uh, this is what happened actually. If you want to imagine what is the function of the dielectric inside the capacitor, just take a look at the few pictures here. Okay, the first picture shows that the first figure shows that this is a field parallel plate capacitor with no dielectric, meaning that because of this is positive plate and this is negative plate, the charge is accumulate at the positive charge accumulate at the first plate and negative charge at the second plate. So the electric field produced between the two plate and represent by E node. E node meaning the electric field without the dielectric. And what happened when we insert the dielectric between these two plate? So because of dielectric cannot, it is not a conductor. It is in the dielectric there is a molecule with a natural molecule. So when the molecule of the dielectric when the electric is inserted between these two plate, what happen is the molecule of the dielectric tend to become oriented with their positive end pointed toward the negative charge. Of course, because we know that if positive charge is interest to the negative plate, right? Same thing with the molecules of the dielectric. For the positive molecule, it will attract to the negative plate, and for the negative molecule, it will pointed to the positive plate. Because of that, if all the dielectric insert between these two plate, what happen is, okay, we will get like this. Okay, so we can see that inside the dielectric all there is a new, it shows the accumulation of the positive plate at this side and negative charge at this side. So it will produce new electric field inside the dielectric, which is represented by ER. So in this case, the new electric field between the two plate is decreased. Why the new electric field between the two plate is decreased? Because of initially in note that the dielectric, when we insert the dielectric, there is a new electric field produced in the dielectric itself, which is represent ER. So we need to inert minus ER. That's why we said that the new electric field when we insert the dielectric is less than the initial inert. Okay, with the dielectric. Okay, so this is the overall very I simplified the concept that relate to the capacitor. Okay, so now we go to the discussion of uh, the question that relate, or Madam Rosmah, you want to
Mm-mm,
announce the
okay.
first? First.
Okay, so Teacher Nun, before we continue our discussion, so I will announce the third and the fourth digit codes for the credit claim. So listen carefully, everyone. The digits are 5, 6. The digits are 5 and then 6. Okay.
Okay,
Okay,
all
Teacher
right.
Nun, you may
Th-
continue.
Thank you, Madam Rosmah. All right. So we go take a look at the question number 1. So a capacitor store 100 picocoulomb of charge. Okay, when it is connected across a potential different of 20 volt. So what you need to do, we need to calculate the capacitance of the capacitor, and also we need to calculate the amount of charge to be removed, okay, from the capacitor to reduce its potential difference to 15 volt. So referring to the question, I just list the information given. For example, just to remind, 100 picocoulomb is pico is 10 power of negative 12. So make sure that you remember the prefix that you learn for in the first semester, right? And then for the first part, we want to calculate the capacitance. So how we want to calculate the capacitance? Because of just now, we have the Q and V. We know that the equation for capacitance is Q over V. So we just substitute correctly the value and you press your calculator. And can you guess the answer? So 1000 times 10 power negative 12. If we say congak, right? It is also can congak. So you will get that 10 divided by 2, it is equal to 5 picofarad. And do take note that the unit for capacitance is farad. Okay. And for the amount of charge to be removed, okay, amount of charge to be removed from the capacitor to reduce its potential difference to 15 volt. So in this case, initially the V, the potential difference is 20. Now we reduce the potential difference to 15 volt. So how many charge that we supposed to remove? So to know the charge that we need to remove, first we need to calculate the charge when the V is 15 volt. Am I right? We need to know. You need to know what is the charge of the capacitor when the potential difference is 15 volt. So to calculate this, we refer to the relationship between the Q and V, which is from Q is equal to CV. We just rearrange the capacitance definition just now. So you get that the Q is directly proportional to the V, and we can use the mathematical relationship, which is I just represent the prime Q prime, which is the charge when the potential difference is 15 volt. Okay. So here to make it clear, also for my reference also, we want to calculate the Q prime first, okay, before we can calculate the amount of charge to be removed. And then Q prime is when V prime 15 volt. So if you substitute the value, because of this is only the mathematic calculation, so you will get that the Q, the charge when the potential difference is 15 volt, it is equal to 75 times 10 power negative 12 coulomb. Okay, is this the answer? No, right? Because of we want to know the amount of charge to be removed. So make sure that you read the question carefully. You highlight what you want to calculate. Okay. So we want to calculate Q final. Okay, which is Q final is the charge that we supposed to remove. Okay. So for the charge to be removed, which is represented by QF, it is equal to initial Q, which is Q when the potential difference is 20 volt, minus with the charge when the potential difference is 15 volt. So when we minus 100 minus 75, it is equal to 25 times 10 power negative 12 coulomb. Clear, right? Actually, it is a very direct question, but you need to read the question carefully. Sometimes the student, they just find the charge when the V is 15. But if you read carefully the question asks you about the charge to be removed. How many charge that you supposed to remove when the potential difference is 15? So meaning that initially we have 5 picofarad. So we need to remove 25 picofarad. We need to remove charge 25 picocoulomb. So that the potential difference can be 15 volt. That's the meaning. Okay. And now we go to question number 2. So for question number 2, what are the maximum and minimum equivalent capacitance that can be obtained by combination of three capacitors of 1.5, 2.0 and 3.0 microfarad? So we want to know what is the value for the total equivalent capacitance, meaning that total capacitance, maximum or minimum value. So what is the maximum and minimum total capacitance that we can calculate from this arrangement of these three capacitor? So what we can do first, we can find the series combination. Let's say if you calculate the series combination of the capacitor, because of we know that for the series combination, the equation is 1 over C equivalent. Okay, so when if you calculate and make sure that you calculate the C equivalent, so it is equal to 0.67 microfarad. Do take note that when you substitute, it is very important for you to substitute the micro. Either you substitute the micro or you write down the times 10 power of negative 6, because of micro is 10 power of negative 6, right? So you can give the answer in microfarad, because of microfarad is one of the unit for the capacitance. And if we compare with the now we cannot decide either this is the maximum or minimum value, right? So you need to calculate the effective or equivalent capacitance for the parallel combination of the capacitor. And for the parallel, if you calculate, we just add on. Remember the table I showed you just now? So to calculate the equivalent capacitance, you will get the equivalent capacitance is for the parallel combination, it is 6.5 microfarad. So now how you want to decide which one is maximum and minimum? Easy, right? So comparing to these two arrangement, the minimum equivalent capacitance is for the series combination, and the maximum equivalent capacitance is referring to the parallel combination. So this is quite conceptual question. Let's say if you try to combine the arrangement, you will get the equivalent capacitance between 0.67 and 6.5. If you not believe, you can try. What I mean is, let's say if you combine a C1, let's say C2 and C3 is parallel. C1 is series with the C2 and C3. So you will get the value in between 0.67 microfarad and 6.5 microfarad. Okay, so for the series combination, we know it will give the minimum value, and parallel combination will give the maximum value for the capacitance. Okay, that's question number 2. Now we go to the question number 3. So for question number 3, figure shows four capacitors. So this is the arrangement of the capacitor. Four capacitors, which is represented by C1, C2, C3, and C4. Okay, arrange between point A and B. And do take note that if you look at these types of circuit, what does it mean by arrange point A and point B? Actually, we just simplified the circuit. Point A and B to meaning that we connect to the power supply. Normally, point A connect to the positive terminal, point B is connected to the negative terminal. Okay, but we not sure because of we understood it is potential difference between point A and B. Okay, and then it stated that the potential difference between point A and B is 12 volt. So you need to calculate the total charge between A and B. Do take note, you need to calculate the total charge. Okay, bukan, not the effective capacitance, not the total capacitance. Read question carefully. So total charge. So given the capacitance of the capacitor, but you need to calculate the total charge. So how? So if you refer to the information given here, so sorry. Okay, sorry. This information is not related. Figure. Okay, because of the different. Okay, it is okay. So if you look at the solution for the effective capacitance, so what you supposed to do first, if you look at the combination of the capacitor here, we can solve the first part of the circuit, which is between the C3 and C4. Do you know how to identify series combination and parallel combination? The clue is for the parallel combination when the current flow. As I said, A is normally connected to the positive terminal. So A, when the current flow, this is the junction. So when at the junction, the current will divide by 3. In this case, there are 3 junction here. So this is parallel arrangement. But the current that flow in this junction, if they flow through the C3 and C4, there's no, the current is not divide. Okay, so it is a series combination. That's the way how we identify the series and parallel arrangement. So C3 and C4 is in series combination. Because of it is series combination, we do the calculation, we use this equation, right? Remember the equation for the series combination of the capacitor? So 1 over C, 3, 4. I just represent the C4 and C3. Okay, so when you calculate, you substitute correctly. And do take note that you want to calculate the C3 and 4. Don't forget to turn it. Okay, when you press your calculator, and you will get the C34 is 1.43 microfarad. So that's the first part. So if I simplify the circuit, okay, so now I have combined the C3 and C4, so it's become like this. Now it is very easy for us to identify the arrangement of the C1, C2, and C34, right? So you also can see here, this is parallel combination. Okay, so sorry, it is not a C34, C2, and C1 is in parallel arrangement, bukan series, not series, sorry. So it is a parallel arrangement. For the parallel arrangement, we just add on the capacitance, okay, of the capacitor, and we get that the effective capacitance for this connection, okay, is equal to 8.43 microfarad. So we just get the effective capacitance, but the question still want us to calculate the total charge between A and B. So to calculate the total charge, now when we combine these 3 capacitors, okay, we get the effective capacitance. Only one capacitor with the potential difference between point A and B just now is 12 volt, right? 12 volt. So to calculate the total charge, we just use the equation for the capacitance, or charge is equal to C effective V Q total. QT is Q total. So our effective capacitance is 8.43, and then our potential difference is 12. So it is equal to the total charge is 101.2 microcoulomb. Okay, so that's the the way how actually we want to calculate the charge, but the process is you need to calculate the effective capacitance first. Okay, so we go to the question number 4.
Okay, Teacher
Or
Non. Uh,
yes,
we have
Madam Rosmaya.
already go live for 35 minutes. So would you like to take a
Okay.
break now?
Okay.
Okay. Stay tuned. Watch the advertisement for the break.
Berita baik untuk semua. Kini, Akademi YouTuber memperkenalkan sistem mata gancaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay, the time run very fast, yeah. Oh, I thought that I explained also very fast, but the time is faster than me. All right, so now we go to the question number 4. An electric flash unit for a camera contains a capacitor of capacitance 850 microfarad. When the unit is fully charged and ready for operation, the potential difference across the plate is 330 volt. So here now it is a correct information given, which is C is 850 microfarad and V is 330 volt. So first we want to calculate the magnitude of the charge on each plate of the fully charged capacitor. Magnitude of charge, meaning that we want to calculate the Q. And B, we want to calculate the energy store in the charged up flash unit. So normally we know that when the flash of the capacitor blink, it is a very high intensity of light, right? It is a lot of charge that used to produce that flash. Okay, so we want to calculate the energy store in the charge hub flash unit. Okay, so the first part, it is just to calculate the magnitude of the charge. We refer to the equation from the definition of the capacitance, which is Q C sama dengan Q over V, or Q is equal to CV. We just substitute because the C is given to us and V is also there. So we just substitute. You will get that the charge on each plate is 0.28 coulomb. Okay, so in this case actually, let's say because of this is stated the magnitude of the charge, you can mention 0.28 coulomb only. But let's say if it's stated that what is the charge on each plate of the capacitor, so your answer is supposed to be, you need to mention because of the question asked you for each plate. So you need to answer because of the magnitude of charge at each plate is equal. The difference is only the sign of charge, which is positive plate and negative plate. So you need to mention, you need to give your answer for both plate. Understand? So it is very important. Sometimes we just do the calculation and we are happy with our answer, but we ignore what is the question actually want. Okay, do take note. Luckily in this case, it's just one the magnitude of the charge. So we just state the magnitude only. No need to state the charge lah. I just put it here to remind you next time if you face the same question, but you need to calculate the charge only. So you need to mention the positive and negative charge. Okay, for the energy store in the charge up flash unit camera, so this is the energy store. So for the energy store, so it is we can use the equation of half Q square over C because we have the Q and also C. We also can use C and V. Okay, we also can use C and V, CV square, or another energy store in the flash, energy store in the capacitor, and you just need to substitute the value, and you will get the energy store in the flash unit is equal to 46.12 joule. Okay, so this is the solution for question number 4. Now we go to the solution for question number 5. So for question number 5, a parallel plate capacitor has a plate with an area of 405 centimeter square. So change to the SI unit, easier. Okay, when you list the information. And F fill gap between the plates that is 2.25 millimeter thick. Okay, the different D. D is the distance between the two plates. Okay, and the capacitor is charged by a battery to 575 volt, and then it is disconnected from the battery. Okay, meaning that initially the capacitor is charged with the 575 volt and then disconnected. So we need to calculate how much energy is stored in the capacitor and the separation between the plate. If the separation between the plate now increase to 4.5 millimeter, how much energy is stored in the capacitor now? Okay, so we want to find the new energy stored in the capacitor if the plate is increased, the distance between the two plate increase. Initially 2.25, now 4.50. So what is the difference in energy? Okay, now we calculate first where, okay, I just do it like this because of when I look at the A and D, I know that we can calculate the capacitance of the capacitor. Am I right? Capacitance of the capacitor without the dielectric, the equation is epsilon naught A over D. So epsilon naught is permeability of the free space. The list of constant is given to you. So the amount is 8.85 times 10 power of negative 12. Okay, you just need to substitute and do take note. The constant is given in the exam paper. And then the A, substitute the A with the correct SI unit as stated. And then the D also you need to change to the SI unit, yeah, because of this is millimeter. So the millimeter for the meter times 10 power negative 3. If you calculate the capacitance, you will get the capacitance of the capacitor is 1.59 times 10 power negative 10 farad. And then to calculate the energy stored in the capacitor with this amount of capacitance for that parallel plate capacitor, we use the equation of half CV square because of V is given. C, you have calculate. C, we consider this is the hidden information lah. Hidden information, okay? So you can substitute in the equation for the energy stored in the capacitor. And then don't forget the square here, CV, V square. So 575 square. And if you calculate, you will get the answer which is 2.63 times 10 power negative 5 joule. Okay, this is the energy stored in the capacitor when the capacitor is charged by the battery with the potential difference of 575. Now, what happened? After that, disconnected. When disconnected and while disconnected, the separation between the plates now increased to 4.5 millimeter. So what happened to energy stored in the capacitor? Can you guess? Do the energy increase or decrease? Okay. Okay, take a look at the solution. So for the second part, which is we want to calculate the energy stored in the capacitor, new energy stored in the capacitor. So what we do is, okay, do take note that I just highlight here for the new energy stored in the capacitor when the battery is disconnected, meaning that for the second case, when the D increase, V is not constant, meaning that the V is not equal to 575 now because of it is disconnected. V is not constant. So referring to for the equation of U, this is also important knowledge. For the equation for the energy store, you need to choose the equation, one of the equation, because of it is the change in distance between the capacitor. What is the relationship between the separation distance between the two plate of the capacitor with the energy store in the capacitor? What is the difference? So to see the difference with from the relationship first, we need to identify which one is constant. So in our case now, V is not constant because we disconnect the battery. So the constant here now is Q. Okay, because of Q is not affected by the separation distance of the plate. Okay, because of Q is constant, so we can find the relationship between the U and C. So between the energy store and the capacitor, which is the relationship is directly proportional. Okay, take a look here. U is directly proportional to the 1 over C. And referring to the equation of capacitance of the capacitor for the parallel plate, we know that the C, the capacitance, is also directly inversely proportional to the D. Okay, and we can conclude that because of U, energy stored in the capacitor is directly proportional to the C, and inversely proportional to the C, and C inversely proportional to D, meaning that U is directly proportional to D. You get this? You can get this? You understand this? U is directly proportional to the distance, referring to this relationship that we get. So from this relationship, we can use the mathematical relationship to solve, to calculate the new energy stored in the capacitor. The new energy stored in the capacitor, which is the new D now is 4.5 milli 10 power of negative 3, and then divide by the initial D, and then times with the initial energy that we have calculated earlier with the distance 2.25 millimeter thickness. Okay, so when you calculate, you will get the new energy stored in the capacitor now is 5.26 times 10 power of negative 5 joule. Okay, so because of, we can say that the U is directly proportional to the D. When the D is increased, the U will increase. Okay, that's question number 5. Now we go to the question number 6. For question number 6, a 10 microfarad capacitor is charged to 500 microcoulomb. If you look at here, I just when I read the question, actually we supposed to list the information given so that we will not miss any info given. And then this capacitor is charged through a 20 kilo ohm resistor. So the first we need to calculate the time constant for discharging process, and then we want to calculate. Okay, actually for the time constant, remember what is time constant? This is the second subtopic, which is about the charging and discharging of capacitor. So times constant, a measure of how quickly the capacitor charge or discharge. If you want to know how quickly, so we can calculate by using the equation of RC. That's the time constant. Okay, so because of that, to calculate the time constant, tau is equal to RC. We just use directly the information given. C and R is here. So we substitute. Do take note that the micro is 10 power of negative 6 and kilo is 10 power of 3. We get the time constant is 0.2 second. It is direct solution, right? You just need to remember the equation for the time constant. Okay. And for question B, where we need to calculate the initial current through the resistor. So what is the initial current? So normally, if it is related to the current, we refer to the Ohm's law, which is V is equal to I naught R. Okay, in this case, I naught, we want to calculate the I naught. We have the R, but we do not have V. So what we can do, we can calculate the V first, referring to the information given. We have the Q and C, so we can get the V. If we calculate the V, you get the V, which is equal to 50 volt. And when you substitute in the equation, you will get that the initial current, which is equal to I naught 2.5 times 10 power negative 3 ampere. This is direct. You need to calculate the V first and then substitute in the Ohm's law. This is referred to your previous knowledge about the equation of Ohm's law. And then for the third one, you need to sketch a graph to show the variation of current against time during the charging of the capacitor. So still remember the table that I show the difference between the charging, discharging, and for the current it is very special, which is the graph for the charging and discharging is equal. So your graph, the graph that you're supposed to sketch is the decreasing of current with time. And there are few important for you to get full marks for the sketching of the graph. You need, of course, you need to write down the axis I and T, and also the value here. For example, this is A naught. I naught initial current. So initial current that you have calculated is 2.5 times 10 power negative 3 ampere. We put it here, and because of for the time constant, which is 0.2 seconds just now, it is equal to 37% from the initial current. Okay, either you calculate or you just notify like that. So this is how to sketch the graph with the correct labeling. Cannot just show the curve graph, but you not label anything. Okay, so Madam Rosmaya, you want to announce the next digit code or
It's
later
okay, you
on?
may continue
Okay,
later.
thank you so much. So we go to the question number 7. So we need to consider the circuit shown in the figure. Okay, this is the circuit shown in the figure. C1 is first charged by closing. Read the question carefully. Yeah, close the switch S1. We close the switch S1, so the C1 will be charged because of connected to the power supply, and then the charge capacitor is connected to the uncharged. Switch S1 is then open. Okay, S1 is open, and the charge capacitor C1 is connected to the uncharged capacitor by closing the S2. So how we close the switch S2? We open the S1, we close the S2. So calculate the initial charge acquired by the C1. Okay, first, what is the charge in the C1? And you need to calculate the final charge on each capacitor. So we want to calculate the Q1, and then we need to calculate the Q1 and Q2 after S2 close. Okay, so this is this is hot question for the capacitor. So there are two things that we want to calculate given the information is here. So to calculate the initial charge of C1, which is represented by Q naught, is equal to C1 delta V, meaning that when we charge, automatically the charge will flow in the capacitor C1. So the amount of charge is 120 microcoulomb. So that's the initial charge when we charge the capacitor C1. At that time, S2 is open. Okay. Now we want to calculate the final charge on each capacitor. Do the charge in C1 still 120 microcoulomb? Okay, take a look, right? So now, as stated in the question, S1 is open, S2 is closed. So when S2 is closed, what happened? They will share the charge because of C1 is fully charged. So C1 will share the charge with C2. The example is like this: if you have $10, you need to share with your friends. So you maybe you will give yourself $6, your friends is $4, meaning that you share the money, right? Same thing. The capacitor is also can share the charge with the C2, but it is depends how many charge that C1 want to share. It is depends on the capacitance of the C2. So we need to calculate. It is not compulsory equal, okay, because it is depends on the capacitance of the C2, meaning that in our case just now, 6 plus $4, it is equal to 10. It is equal to initial money, right? So same thing with this charge. When we share, when C1 share the charge, so Q1 plus Q2, meaning that the charge that's supposed to be given to the C2, when we add these two, it is equal to 120 microcoulomb. You can accept that, right? That statement? Because of they share the charge. So here, from this concept, we know that Q1 plus Q2. So this is all we can write down because we have no value for Q1 yet. We want to calculate Q2 too. Q1 and Q2, right? So we get that relationship, and we know that when Q1 plus Q2, remember the table for the arrangement of the series and parallel combination. So Q1 plus Q2 meaning that C1 and C2 are parallel arrangement. If you just look at the circuit, it's look like that it is a series combination. But when we understand the concept of sharing charge, actually it is a parallel arrangement. What is the important when you know it is a parallel arrangement? It is about the V. For the parallel arrangement, the potential difference across V1 and V2 is equal because of it is parallel arrangement. So when V1 is equal to V2, but we don't know the new V1 and V2, right? So we can use the relationship since we want to calculate the Q1 and Q2. So we can use this relationship Q1 over C1 equal to Q2 over C2, which is Q1 over C1 represented by V1, Q2 over C2 is represented by V2. Okay, now what you need to do? Next, because we have the capacity of C1 and C2, so we just substitute in the equation. So for the Q1 here, we have the relationship. Q1 is equal to 120 micro minus with Q2. So we just substitute Q1 here and we can calculate. First, we calculate the Q2. So we get that the charge in the Q2, in the C2 is equal to 40 microcoulomb from the calculation, right? Right? You need to calculate. Okay. So I just put micro here, easier. Actually, we can cancel the micro so you can shorten your calculation. And because we want to calculate charge on each capacitor, so this is Q2. How you want to calculate the Q1? Just substitute Q2 in the Q1, right? So when you substitute Q2 in the equation of Q1, you will get that Q1 is equal to 80 microfarad. So it is very important for you to understand the concept of parallel and series combination of capacitor. Here are really hot, higher order thinking skills question that you need to think in the opposite side. We think that it is about the sharing charge and it is you identify it as a parallel. Okay, is it clear? So this is final charge on each capacitor represented by Q1 and Q2. Now we look at the question number 8. For question number 8, the dielectric of the parallel plate capacitor is to be constructed from Teflon. So Teflon is the dielectric because of dielectric, and fill the volume between the plate. The area of the plate is 0.5 meter square, and given the dielectric constant for the Teflon is 2.1. So what is the thickness of the Teflon in the capacitance if the capacitance is to be 0.1 microfarad? So the thickness of the dielectric between the two plate, what is the is the thickness of this dielectric. So how we want to calculate the thickness, and number B, we want to calculate the charge on the capacitor if it is connected to 12-volt battery. Okay, so first to calculate the thickness, which is D, we refer to the equation for the capacitance of the capacitor with the dielectric, because we have the dielectric constant, which is epsilon R. Epsilon R is dielectric constant given by 2.5. Epsilon naught, as I said, permittivity of the free space, the list of constants there, and then area is zero point 0.5, capacitance is zero point 0.1 micro. So when you calculate, you will get that the D is equal to the distance between, or the thickness of the Teflon, which is represent the distance between the plate lah, because of the Teflon is fill the volume between the plate. Okay, the Teflon fill the volume between the plate. That's why it can be represent, the thickness of the Teflon can be represented by the distance between the two plates. Okay, and then for the charge on the capacitor, we use the equation for Q, which is equal to CV. You just need to substitute the C capacitance and the given V, potential difference, which is 12 volt. So you get 1.2 microcoulombs. That's direct question. Okay, and then we go to the question number 9. So for question number 9, explain clearly. Okay, this is quite interesting. This is because of I have explained about the what happened when we put the electrode, when we insert the electrode, what happened the situation. So this is the application. Okay, if you understand what happened when we insert the electrode, so you can explain the explanation or conceptual question. Okay, so referring to the question number 9, explain clearly why the electric field. Do take note. We want to discuss about the electric field between the two parallel plate of the capacitor decrease when the electric is inserted and the capacitor is not connected to a power supply. Meaning that why electric field will decrease when the dielectric, when we insert the dielectric and the capacitor is not connected to the power supply, but remain the same, meaning that the electric field remain the same when it is connected to a power supply. Okay, the question is also quite confusing, right? Okay, take a look at the solution carefully. Okay, initially we have a two parallel plate air field capacitor. So between these two plates there is a inertial. So I just represent E naught, which is represent the initial electric field. So this is the electric field without the dielectric. So E is equal to E naught. Okay, you understand, right? That's very basic. Okay, now we put the dielectric. So as I explained initially at the early class just now, when we put the dielectric, the the electric field will produce in the dielectric cause the new electric field decrease. Am I right? That's I explained earlier, right? So you can say that when you want to explain, you need to explain electric field, which is the new electric field, will decrease when the dielectric is inserted. Why? Because of the molecule of the dielectric are polarized, produce the magnetic field inside the dielectric, and it is opposite the direction with the initial electric field. So initially magnetic field from positive to negative plate, right? But in the dielectric, the magnetic field of the dielectric is from the positive to the negative also, but inside the dielectric itself. So the electric field is decreased. So we explain the first statement. Okay, because of this capacitor is not connected to power supply, so that will happen. The electric field will decrease. But what happen if we connect to the power supply? Okay, so okay, this is to show that the new electric field is decreased. Okay, E naught initial to the right minus ER to the left. So the E new will decrease. So in this case, when it is connected to the power supply, okay, take a look here. When we insert the dielectric and we connect it to the power supply. So why the E electric field is remain the same? Okay, how you want to explain? So I just represent here as V naught, potential difference across potential difference of the battery. So if the capacitor power supply, if the capacitor connected to the power supply, more charge flow into the capacitor until the V is back to initial V naught. Of course, meaning that when the decreasing of the charge will cause the power supply will charge back. We charge back the capacitor until when? the charge is entering the capacitor until the potential difference across the capacitor equal to the potential difference of the power supply, meaning that fully charged. Okay, so in this case, if you want to see the relationship, E is referring to the capacitor, E is equal to V over D, and E is directly proportional to the V, meaning that the electric field is directly proportional to the potential difference. So in this case, potential difference, when we connect to the power supply, potential difference of the capacitor is remain the same. Am I right? Potential difference is same because of it will charge back the capacitor. So E will constant or E will remain same as initial. Okay, that's the explanation. This is very special because you need to understand this part. Okay, and maybe we can go to the last question. Okay, last question is quite simple, which is about the capacitor with the dielectric. Take a look at the question. An air-filled parallel plate capacitor has rectangular plate with dimension of 6 times 10 power of 8 centimeter. So I calculate from this dimension, we get the area, and it is connected to 12-volt battery. While the battery remain connected, a sheet of 1.5 millimeter thick paper is inserted and completely fill the space between the plate, meaning that the paper is the dielectric. The paper is represent the dielectric. So given the dielectric constant for the paper is 3.7, so we need to determine the change in the charge. Okay, take note that the change in the charge, storage in the capacitor. This is also a hot question because I take look, change in charge. So change in charge, okay, because of the dielectric insertion. So change of charge is equal maknanya, meaning that kalau change mesti Q final minus Q initial. If you look at the information given, do we have the initial charge? Do we have the final charge? No, right? So we need to calculate. First, we need to calculate the initial charge. So referring to the equation, we have AD. Okay, so we can calculate the initial charge. Initial charge, but calculate the capacitance without the dielectric first. So capacitance without the dielectric is represented by epsilon naught A over D. We just substitute the value. A is here. We have calculated earlier. Substitute. You get the capacitance without the dielectric or F field parallel plate capacitor. No dielectric yet. So it is equal to 2.83 times 10 power negative 11 farad. And then from here, you can calculate the initial charge. So initial charge, we just use the equation and you will get that initial charge is equal to 3.4 times 10 power negative 10 coulomb. This initial charge. So now we want to find the final charge. So how? Of course, for the final charge, we need to consider that the dielectric is inserted between the two plate of the capacitor. So we can use this relationship. Remember the relationship between the capacitance with the dielectric and the capacitor without the dielectric? We just time with the epsilon R. So more faster to calculate the capacitance. Okay, you will get. You also can use equation for epsilon R, epsilon naught A over D, but it is you waste your time because it is a lot of things that you need to press in your calculator. So referring to this one, you can calculate the capacitance for the capacitor with the dielectric, which is equal to 1.05 times 10 power negative 10 farad, and you can calculate the final or the charge with the dielectric, charge of the capacitor. So we use the capacitance here, we substitute the same amount, and then you will get the charge is 1.26 times 10 power of negative 9 coulomb. Okay, is it finished? Not yet, because we want to calculate the change in charge. So do take note that change of charge is Q final minus Q initial. So because of that, referring to the previous calculation, the initial Q naught, which is 3.4 times 10 power negative 10, and then final charge is 1.26, where we minus 2. This one, you will get that the change in charge is equal to 9.2 times 10 power negative 10 coulomb. So this is the change in charge storage when we insert the dielectric between the two plate of the capacitor. Actually, the step is quite long, but it is a repeating, calculating the charge before insert and after inserting the dielectric. Okay, so I think that's it. This is only the question that we will discuss for today's class. The time is also out. So I hope that I wish you all the best and good luck. So I give back to Madam Rusmaya. Thank you,
Okay.
Madam Rusmaya.
Okay, with God's grace, we have reached the end of today's session. So congratulations to all those who are able to follow our session from the beginning till the end. So before we end our session for today, I will announce the 5th and the 6th or the last 2 digits code for credit claim. Okay, so the digits are 4, 4. Okay, 4 and then 4 again. Okay, the digits are 4 and then 4 again. Okay, so all of you, please stop posting your comments for a while. And if you haven't clicked the subscribe button, so please do so. Make sure it turns to grey color, not the red color. And activate the icon bell so that you will not miss the next class session. So then if you find that the lesson was beneficial, click like and share to your friends on your social media. So spread and share the goodness. Okay, once completed, type done on the chat box before the certificate link and credit claim link are given as a token of thank you for your dedication in joining the free class online today. So I will paste the link now. Okay. Okay, the link for claim credit. Another one is the link for certificate. Okay, so the certificate link and credit claim link are already given in the chat box. So please take note, the link will end half an hour after this live. So make sure to use the EDD email or more email only to log in. So incorrect email used will not be entertained. So if you haven't got one, please apply the link to apply the EDD email is also given in the chat box. So if you wish to get more information on the online classes, so go to www.academyyoutuber.com. Okay, to those who haven't joined EDD Junior Telegram, please do so. And so once again, I would like to thank all of the students for joining today. Remember that the more classes you join, the more credit you can claim. So feel free to share this free tuition class to your friends and teachers all over Malaysia. So this is a collective effort from all the teachers throughout Malaysia for all the students throughout the country. So thank you too for being a YouTuber Academy supporter too. So I think that's all for now. See you in another session. Ingat hashtag, okay, bermula percuma, selamanya percuma. So Assalamualaikum, stay safe till we meet again next week on the same day and the same time on Sunday at 5 p.m. Okay, bye-bye.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang. Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.